During a solar eclipse, the moon fits so perfectly over the sun that it shields its blinding light, providing astronomers with a view of the star's atmosphere otherwise impossible to experience. At the moment of totality, the pinkish arc of the chromosphere, the atmosphere's innermost layer, becomes visible, and with it a rainbow-like band called the flash spectrum appears when the sun is viewed through a prism. The eclipse of 1870 led to an understanding of the structure of the sun's chromosphere and the discovery of helium, the second most abundant element in the universe.
The spectrum is probably the single greatest source of information about a star. And it was during a couple of historic eclipses in the 19th century that astronomers figure out how the spectrum of the sun is produced. And they only were able to figure it out because of the particular circumstances during a total eclipse.
These circumstances are both precise and crucial. If our moon was slightly larger, it would partially block our view of the chromosphere and diminish its spectral light. A smaller moon would allow too much light from the sun, destroying our view of the solar atmosphere and the flash spectrum.
And so you have to have a nearly perfect match between the sun and the moon, so you don't hide the chromosphere. And that insight afforded by eclipses in the 19th century is what finally permitted astronomers to figure out how the spectra of distant stars are produced. Really, that opened up stellar astrophysics and allowed us to understand how other stars work, because distant stars, after all, are other suns.